Now, still on dehydration of alkanol that we just finished in the previous video, we want to look at the rates of dehydration of alkanol to form an alkene. The rates of dehydration of alkanols. Now, the hint is this: rate of dehydration is dependent on the class of alkanol or carbocation intermediates. The rates of dehydration depends on the class of alkanol or carbocation intermediates. Remember, let's just recall the mechanism of dehydration of alkanol, where an alkanol C H H C H H O H in the presence of an acid. The acid protonates, and what happens is that one of the lone pairs of electrons move into the proton, and the proton covalent bonds with oxygen to form an oxonium compound, which is R CH H CH H O bond H plus. This is an oxonium ion. Now, afterward, the oxonium ion react again. And the reaction of oxonium ion is that of the elimination of water, where, because oxygen is even more electronegative, it will break this bond. The lone pair of the bond pair here move into oxygen to eliminate water. And we have this establishment of carbocation with elimination of water. Now, this type of carbocation, the carbocation is stable, is a stable compound, is a stable intermediate. Now, the stability of the carbocation determines the rates of dehydration. Finally, what happens here is where one of the hydrogen ions gets lost. Deprotonation. One of the hydrogen ions gets lost to form ethene. R C H H H H plus. Now, one of the hydrogen ions will get lost by breaking its bond into this bond, and we have R C double bond H C H H plus H plus, and this H plus goes for the formation of reproduction of the acid that started this reaction. Now, the kind of carbocation formed depends is what determines the rate of reaction. And we have three classes of alkanol. Three classes. You will see that this is a primary alkanol. And this primary alkanol forms a primary carbocation, RCHH plus. This is primary carbocation. And we have secondary alkanol. Secondary alkanol, which forms secondary carbocation. This is secondary alkanol, which forms secondary carbocation, which is CHR prime plus secondary carbocation. So we can summarize by saying that this is primary carbocation, and this is secondary carbocation, and this is tertiary carbocation. Now, these carbocations, their stability. The alkyl group attached directly to this carbocation determines the stability. Alkyl groups are electron-donating groups. So if we have one alkyl group here, and we have two alkyl groups here, and we have three alkyl groups here, it means that the stabilization increases with increase in number of alkyl groups. So this is stable. This is less stable. Sorry. This is stable. Less stable. and least stable. Carbocations are stable, but the most stable, the least stable is primary carbocation, which has only one electron donating group, which is one alkyl group that produces a stabilization of the positive charge of the carbon. But here we have two alkyl groups that donate electrons to cause stabilization of the positively charged carbon. But here we have three of them. So this one should be the stable one, and this one is less stable, and this one is least stable. Which means the rate of dehydration that we said depends on the carbocation or class of alkanol is now summarized like this. Rate of reaction of rate of dehydration of alkanol is arranged like this. Tertiary carbocation, okay, tertiary alkanols have the highest rate, followed by secondary alkanols. And the least rate of reaction is that of primary alkanols. Or you can say something like this. You can say something like this. Tertiary has the highest rate, followed by secondary. And the least is primary. And this is the rate of dehydration of alkanols. Thank you for watching. Have a nice day.